Yes. 3 coins are tossed. State the possibility space. Let us first list down the possibility space. So the sample space is the same as possibility space. The sample space, we have just said here, sample space includes all possible outcomes. All the possible outcomes. So you might get a head-head. There are 3 coins. All the coins may show you the head. Is that clear? You can also get head, then tail. Is that clear? We can also get head, tail, head. That is also possible. Then we can have head, tail, tail. Is that clear? We can get tail, yes, tail, head, head. What else? We can also get tail, head, tail. We can get tail, tail, head. Then lastly, tail, tail, tail. Those are the possible outcomes when you toss 3 coins. When you toss 3 coins, you might get all the faces showing heads. 2 faces showing a head, 1 showing a tail, another one head, tail, head, tail, tail, etc. So now we have got the sample space. What about NS? The number in the sample space. They are 8. So since they are 8, therefore you write 8. Okay? Yeah. Then can we start answering the questions? Probability of getting 3 heads. The event is 3 heads. So therefore, NE is equal to how many? Well, we have 3 heads. There is 1. It is only 1. So what is the probability of getting 3 heads? Probability 3 heads is going to be equal to NE over NS, where NE is 1, NS is 8. So the probability is 1 over 8. Is this clear? Yes. Okay, let's look at the probability of getting 2 heads. Probability of getting 2 heads. Is that clear? Yes. Now, the event where we have 2 heads. 2 heads. You go back in the sample space and look for 2 heads. We have HHT, isn't it? We have HHT. What else? HTH. We want where we have 2 heads. HH. TH. H. That's all. So those are the events. What about any event? The number of these events? There are 8. There are 3. So what about NS? The sample space, it is 8. Therefore, probability of the event is NE over N over NS, which gives you NE is 3, NS 8. This is the probability. Huh? The event in the first one. You wanted me to list it down? And we want only 2 heads, and the other one is 3 heads. Heads big ate go ziri heads esatu. You cannot include it. Giri emitwe giri esatu, twagala mitwe ebiri. Last year it was at most one. At most one head. At most one head. At most one head. Here we want the biggest number to be one head. One head. Is that clear? So you go back in the sample space and you look for those occurrences where you have at most one head. One head and a big low. That means one head and no head. Yeah? Yes. At most. Most is so can you give me the events there? At most one head. THT. You follow the order as they are in that order. Which one? H, T, T, at most one head, T, H, T, T, H, T, 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 H, T, T, H, no. There is also T, T, T. You said, because I said at most one head. The biggest number should be one head. But even when there is no head, you will consider it. Yeah? So what is NE now in this event? 4. These are 4. What is NS? 8. So therefore, probability of this event will be equal to NE over NS, which is equal to 4 over F. By 4 once by 4? So the answer is a half. And we'll take them HH, or one was of Fula heads in the car. I don't know a Singapore would then not wear a head. And put out a twin. Put out a Satu, the woman's of Suka, articles to one way. Father is in the old energy, on Toguchi. Okuda wansi. Akati okuda wansi zile vile wansi. Roll the ones. A fair die. is rolled once. Calculate the probability. Calculate the probability of getting. Calculate the probability of getting an even number. An even number. B, a prime number. A prime number. Prime number. C, a score of 6. A score of 6. C, D, a score of 10. So, can we look at this? A fair die. When we say a fair die, it means a die where all faces have the same chances of appearing. That's clear. That's why it is fair. It is fair. So, what are the possible outcomes? Let us pass this down. The sample space. Sample space. Sample space or a die. Stop right here. Get this thing. Sample space on the die. You know a die has how many faces? 6. There are 6. And each face has a value on it. So those faces contribute to the sample space. Because they all have the same like outcome. So we have face 1, 2, 3, 4, 5, and 6. That is the sample space. So what about NS in this case? The number in the sample space. There are 6. There are 6. Are we together? Now, can we begin answering the question? An even number. So, the event is even number. So, event is equal to even numbers. Even numbers. What are the even numbers we have? 2, 4, and 6. So, what is NE? The number in the even number, number of even numbers. There are 3. Is that it? So, how do we get this? The probability. So, probability PE is equal to NE over NS. Where NE is 3 and NS is 6. Therefore, we say we can reduce the probability. Yeah? It becomes a half. Sure. I think it is easy.
It is.
Yeah?
It is.
It is beginning.
Yes, the beginning is.
Easy. We are going to start the easy things only until the end of the Yes. Everybody must pass. Except can we need for prime numbers? Yeah?
Yes, sir.
So the event is in prime numbers. What is a prime number?
It is a number that has two factors, 1 and itself.
A number which has two factors, 1 and itself. So can you give me the prime numbers from among this sample space? You people, you don't know prime numbers. It's prime and what's the prime number? Yeah. It is 2, 3, and 5. The numbers are 2, 3, and 5. In this case. But prime numbers are 2. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 86. Those are the prime numbers. Why you should put this in your hand is because when you are prime factorizing, you will need them. When you are looking for LCM, you will need them. When you are looking for highest common factor, you will need them. Am I clear? I didn't know.
1 is not a prime number.
1 is not
9.
9. Did I put it there?
No.
He's asking why is it not a prime number?
9 is not a prime number because it is divisible by 1. You can divide it by 3 and 9 itself. So it has 3 factors. Okay, can we come back here now? The events are prime numbers. The prime numbers in that set are 2, 3, and 5. So NE, in this case, these are 3. Huh?
Yes.
They are 3. NS, the sample space, they were 6. So, probability therefore, yeah, PE is equal to NE over NS, which gives you 3 over 6. And it is the same as half. Yes. We'll go to the next one. A score of 6. So the event is score of 6. We know 6 here. So NE therefore is equal to 6. You can take only one score of 6. See. Okay? So it is 1. What about NS? 6 is 6. So PE is equal to NE over NS 1 over 6. That is the answer. So you can score 6 once in 60 chances. That's the event. Then lastly, it is a score of 10. So the event is score of 10. The score of 10 is an empty set because we don't have 10 in the sample space. Huh? That probability is not likely. Cannot happen. Okay? You cannot score 10 on a die because the highest score on the die is 6. Therefore, you are going to get What is NS? Is
6.
is 6. What about NE?
0.
NE is 0. Actually, NE is 0. NS is 6. Therefore, probability is equal to NE over NS, which gives you 0 over 6, which is equal to 0. Some people, when they divide 0 by 6, they get 6.